Hi everyone and welcome to my channel again. Today I have a different problem and we have a cubic equation x3 minus 3x plus 1 equals 0, and the problem wants us to find the sum of power 6 of all the roots. So x1, x2, x3 are the roots of this equation here. So these guys are satisfying this equation and we would like to find this sum. So one obvious way to solve this problem is to literally try to find the roots x1, x2, x3 using famous formulas for cubic equation, and then plug it into this expression x1 to the power of 6 plus the rest of it, and then try to calculate the expression. Well, that's a very straightforward, I would say naive way, but there is a better way to solve this kind of problems. Not only for cubic equation, but literally for any such type of problem. Before I do that, let me first define some expressions. So let's define xn to be the sum of power n of all the roots. So this is the most general form. So Sn is x1 to the power of n plus x2 to the power of n plus x3 to the power of n. And in order to find a general relationship for Sn, so what I do, I come and take this cubic equation and then multiply both sides of it by x to the power of n minus 3, obviously n minus 3 because then it cancels 3 here and it produces a term such as xn. So that's the reason, and if I do that, then I get n minus 3 times x3 minus 3x plus 1. This is equal to 0, and as a result, xn minus 3, xn minus 2 plus xn minus 3. This is equal to 0. Okay? But also pay attention that x1 and x2 and x3 were the roots of this equation, then obviously they are going to be the roots of this equation of order n as well. So I can say then x1 to the power of n minus 3, x1 to the power of n minus 2 plus x1 to the power of n minus 3. This is 0. I can also say the same things about x2 and x3. So x2 to the power of n minus 3, x2 to the power of n minus 2 plus x2 to the power of n minus 3. This is also 0. And the same about x3. So this and minus 3x3 to the power of n minus 2 plus x3 to the power of n minus 3. This is equal to 0. So as you probably by now have guessed, so in the next step I'm going to sum all of these equations with each other, because if I do so, these first terms here, well, these guys are gonna produce this Sn for me here. And it will give me a beautiful relationship between Sn and s minus 2 and minus 3. So if I do that, then the relationship which I get is this: Sn minus 3 Sn minus 2 plus Sn minus 3 equals 0. Or in other words, I can say Sn equals 3 Sn minus 2 minus Sn minus 3. Okay, this is very nice. By the way, n should be definitely greater than equal to 3. Okay, otherwise, yeah, when I multiplied it here by x to the power of n minus 3, it doesn't make sense. N minus 3 should be greater than equal to 0. So I have this beautiful relationship here, and I'm going to use this to find this sum. Obviously, that sum is nothing but S6. Well, that's just the definition. So the relationship tells me that then S6 must be equal to 3 S4 minus S3. So I need to find S4 and S3 in order to find S6. So in the next step, I'm going to calculate S4 first. So what is S4? S4 can also be written as, according to this formula, can also be written as 3S2 minus S1. Okay? Now I have to find S2 and S1. So let us take the equation which we had here, x3 minus 3x plus 1 equals 0. So this is the equation which we had. just for a moment, x3 minus 3x plus 1 equals 0. We know that this equation, if we, well, assume that we have x1, x2, x3, can be factorized as the following, that x minus x1 times x minus x2 times x minus x3 equals 0. So basically, yeah, if x1, x2, x3 are the roots, it can be factorized in this way. But if I expand this expression here, what I get is basically this one, x3 minus x1 plus x2 plus x3 times x2. Then I get plus x1, x2 plus x1, x3 plus x2, x3, x minus x1, x2, x3. This should be equal to 0. And if I say, well, if I put these two guys, if I consider them as equal equations, then what the conclusion I get, by the way, this is nothing but S1, right? Because n is 1. Then the conclusion that I get is that basically the coefficients must be the same. So as a result, we have minus S1 should be equal to 0 because x2 does not exist in the equation. Then the coefficient is 0, and then I have another relationship, which is basically x1, x2 plus x1, x3 plus x2, x3. This is equal to the coefficient of x, which is basically minus 3. And then minus x1, x2, x3, this is also equal to 1. Okay, at least I got this one. S1 must be 0. So, and this was also what I was looking here for, right? So it helps me there, definitely. And I just need to find S2. S2, okay, I cannot use this equation here to find S2. Why? Because n should be greater than or equal to 3. But maybe actually I can find S2 in a different way. So let's say, well, what is S2? According to the definition, it was x1 to the power of 2 plus x2 to the power of 3 plus x3 to the power of, oh, I'm sorry, this must be 2. So basically sum of power 2 of all the roots. And well, there are famous algebraic identities. And for this one, we can basically use this famous one, which is basically x1 plus x2 plus x3 to the power of 2 minus 2 times x1, x2 plus x1, x3 plus x2, x3. Okay, and this is nothing but S1, and S1 we already have it, is 0, and this guy also we already have it, is minus 3. So then this is 0 minus 2 times minus 3, which basically gives me 6. So S2 is 6. And going back to this equation here, so S4 is 3S2 minus S1. Therefore, as a result, S4 is 3 times 6 minus 0, which gives me 18. Okay, we got S4. We got S4, and now we have to calculate S3 as well, because that's also in the equation there for calculating S6. So let us go back to S3. And S3, again, according to the formula which we had up here, we can use S3 because n, can be 3. So it is nothing but 3S1 minus S0, okay? But S1 is 0, we already know, and S0 is, by the way, is the power 0 of all the roots. So basically it's x1 to the power of 0 plus x2 to the power of 0 plus x3 to the power of 0, which is basically 3, okay? Then this is 0 minus 3, and this is minus 3. So we already also have S3, and as a result, we get S6 equals 3 S4 minus S3, which basically gives me 3 times 18 minus 3 plus 3, and that is 54 plus 3, which is 57. I hope that you enjoyed this solution. If yes, please consider to subscribe to my channel and also like this video, and I will see you next time for more interesting problem.